Okay, so if Coulomb's law take the form kq and q2 upon r k power 2 plus del, then the electric field ER, like it can be derived from my minus dv upon dr also. And electric field will be given by minus kq upon r k power 2 plus del. So I have written kq upon r k power 2 plus del here. So kq upon r square is kq upon r k power 2 plus del, and this is like dr. Try to integrate this. What I will get from integration, this is what I want to find. So for example, here if you have this point charge q written all over, so it will be like minus kq upon r k power r k power minus 2 minus del plus 1 divided by minus 2 minus del plus 1. So x ki power n integration is x ki power n plus 1 upon n plus 1, isn't it? So this is from r. There is again negative sign. So इसको ऐसे कर देते हैं, r यहाँ लिख देते हैं. Is that clear? Infinity पे 0 होगा, है ना? एक नेगेटिव और आ रहा है. Is that clear? So instead of infinity to r, I have written it from r to infinity. I have absorbed this negative sign. Integration would be this. So v as a function of r would be equal to, I think, it will be equals to k, q, and you take this infinity, you will have 0. If you take this r, this will be r ki power minus 1 minus del divided by minus 1 minus del, and then because this is infinity, this will be 0, and minus minus again a minus. So overall, this potential as a function of r, you will get this. So potential as a function of r, you will get k q upon 1 plus del, and then you have this r ki power 1 plus del. So this is what you will get. So your potential as a function of r, you will get kq upon 1 plus r, 1 plus del r ki power 1 plus del. Is that clear? Okay. I hope it is clear till now. So potential as a function of r, you will get this. So this is the expression which you derive from your field, like now new field. Because actually, what we were trying to do when we were doing this thing, like eventually in the previous lecture, I made a mistake here. So what I was trying to do, I was thinking that my potential, if I know for my field, if I know my potential for a ring, then all these potential when added would give me the result. But I forgot that the law itself has changed. So this is what we were trying to find. So let us first find the changed potential first. So the changed potential due to point charge would be kq upon 1 plus del r ki power 1 plus del. This would be the change potential. And if this is the change potential, now let us again do this problem. What I'll do, simply copy this stuff out. Okay, this I cannot take as a whole. So just give me a minute. So if I check it again, so this is my this is my sphere. Okay, so this is a mistake that we were doing in the previous lecture. You understand this particular thing first. What is the mistake? The mistake was actually what happened was while I was doing this, I forgot that I am having now the new electric field expression. Now, if I was relying on these formulas were only when your electric field was 1 upon r square. So now you can no longer use these formulas. So what I would do, I would first find the newer potential. So I will have to first find the newer potential. So I found the newer potential to be equals to kq upon 1 plus del r ki power 1 plus del. Is that clear? So if you have this newer field, which is like kq upon r ki power 2 plus del, if you want to find the potential from this particular field, you will get the potential to be kq upon 1 plus del r ki power 1 plus del. Now, if this is your potential function, what you can do, this is your sphere. Okay, in this sphere, this was your slice, and this particular slice is like whatever small ring I'm taking. And let us understand that if it contains charge dq, let us understand that if it contains charge dq, so let's, if this is the charge dq over here, so what would be the uh, what would be the potential at point P? What would be the potential at point P due to this particular small ring? So due to this particular small ring, I'll write phi due to ring would be equals to what? Would be equals to K dq upon 1 plus del. Instead of now, this will be the expression, isn't it? And here I think I took this as LR. I think I took this as origin. I had this some capital R, and I think this distance was L, isn't it? So instead of R, I will write simply L. Is that clear? ये चीज समझ में आ रही है कि ऊपर से गई है सारी? कल्पना ही रह गई, सिर्फ कोई नहीं रह गया बाकी. Is that clear और नहीं clear? प्लीज बोलो.
कोई दिक्कत नहीं है.
ठीक है, तो k dq upon 1 plus del, and this is L की power 1 plus del. Now all these rings when integrated, so understand ये सारी integrate कहाँ से कहाँ तक होगी. देखो, अगर इस रिंग को पकड़ोगे यहाँ से छोटी सी रिंग को, और फिर धीरे धीरे if you take all these rings together, so your theta would change from 0 to pi. So I will, in order to find the total potential as a function of r at point P, I will have to integrate from theta equal to 0 to theta equals to pi. And this will be k. What is my dq? Again, I will have to see my dq would be equals to, वो शायद कहीं ऊपर लिखा है हम लोगों ने. So dq is, I think, q sine theta d theta divided by 2. So this will be q by 2. I will write here. So I will write q by 2 sine theta d theta, and I have this 1 plus del. I have L की power 1 plus del. Is that clear? यहाँ तक तो I don't think there is an issue. So this will be kq sine theta d theta upon 2 1 plus del L की power 1 plus del. और L क्या है खुद सोचो. L I think is equals to phi as a function of r is like varying theta from 0 to pi, and this is k, this is why I'm writing capital Q. It was capital Q only, na? Capital Q. This is sine theta, and then I will have to write d theta. I will have to write 2. I will have to write 1 plus del, and then this r I will write. I think L was r square plus small r square minus 2r capital R small r cos theta का root over raised to power 1 plus del. I think this is clear. Now, if I want to, like here it is cos theta, here it is sine theta. So I'll take let capital R square plus small r square minus 2 capital R small r cos theta be equals to what? T. And if I differentiate this thing up, I will get minus 2 capital R small r sine theta d theta is equal to dt. So I can write my sine theta d theta as dt upon 2 capital R small r. So I will write it as phi as a function of r. Forget about theta right now. I'll change all these things in theta later on. But this will be like k capital Q, and sine theta d theta I can write it as dt upon 2 capital R small r. Then again I have this. अगर इसको थोड़ा ध्यान से देखें, I am certainly not making any mistake, isn't it? So एक काम करो, उसको t square ही ले लो, जिससे कि मात्रा बहुत सी. So this is like t square की हो जाएगा 2t dt. This would be 2t dt, so at least ये cancel out हो जाएगा. So instead of sine theta d theta, you can write dt upon capital R small r. You have this 2 here because of this. You have this 1 plus delta because of this. And then you have this t, I have written as square. So square. And then this is, I think, 1 plus del. थोड़ा सा लंबा हो गया, पर कोई बात नहीं, जो है जो है. ठीक है. Try to integrate it and then reimpose this, like, try to integrate it with respect to t, then try to write it in this t as a function of small r and theta, and then we'll use these limits of theta. So overall, this will be like kq upon 2 capital R small r 1 plus del, and then this t की power 1 plus del will give you t की power. Is that clear? I mean, इसमें कोई गलती तो नहीं कर रहे हम लोग?
यहाँ तक तो सही है।
पक्का ना? कोई गलती हुई तो फिर अपन कचरा हो जाएगा अपना।
हाँ, यहाँ तक और कुछ एक्सपेक्ट किया ही नहीं था, यहाँ तक तो ठीक है।
है ना? 100%. So I have taken this as t square. This is 2t sin. अच्छा, एक और भी गलती हुई है, इट इज टी डी टी, तो यहाँ पर टी भी तो आएगा. ओके, सो अगर यहाँ टी आएगा तो एक आएगा टी की पावर. अच्छा, ये टी कैंसिल हो जाएगा, इसका मतलब क्या होता है? इट इज लाइक टी की पावर डेल, सो दिस इज लाइक टी की पावर 1 माइनस डेल अपॉन 1 माइनस. इज इट क्लियर? और अभी काम करते हैं, इस पूरे को बाद में एक साथ ही लिख लेते हैं. सो फाई एज अ फंक्शन ऑफ टी यदि आ रहा है तो फिर मैंने लिखा के कैपिटल क्यू अपॉन 2 कैपिटल आर स्मॉल आर. दिस इज 1 माइनस डेल स्क्वायर, and this is t की power 1 minus del. T की power 1 minus del is I think r square plus small r square minus 2 capital R small r, and this is I think cos theta, and this is I think 1 minus del upon. Is that clear? Is that clear? यहाँ
यस।
तक कोई दिक्कत तो नहीं? अब एक काम करो,
हाँ
थीटा
नहीं।
की इनिशियल लिमिट लो थीटा इक्वल टू 0 और फाइनल लिमिट लेते हैं थीटा इक्वल्स टू पाई. इज दैट क्लियर? इसके वजह से क्या होगा, ऑल दीज थिंग्स वुड बी कवर्ड अप. देखो ना, अगर if your ring was here then theta was 0, and if your ring was there on the farther end then your theta would have varied from 0 to 0 to pi. Sorry, if theta varied from 0 to pi, this will give me total contribution due to entire these rings. So in totality I will get the potential due to this entire sphere. Is that clear? यहां तक समझ में आया कि ऊपर से चला गया? So phi as a function of r, कुछ इसका काम कर ले क्या, नहीं तो दिक्कत होगी. एक काम करते रुक जाओ. ठीक है, यहां तक आई थिंक इट्स क्लियर. दिस विल बी लाइक equivalent. If you write this pi, so cos pi is -1, so this will be kq upon 2 capital R 1 minus of del square, and then अगर आपने थीटा इक्वल्स टू पाई रखा, थीटा इक्वल्स टू पाई रखोगे तो कितना है? cos pi is -1, दिस इज r square plus small r square minus 2 capital R, so this is r plus r का whole square की power 1 minus del. So always remember root over r square, yeah, root over x square is mod r. So what I will write, this will be like, what should I write? R plus r का mod की होल पावर 1 माइनस डेल. तो हो गया क्या? हमेशा याद रखो, रूट ओवर एक्स स्क्वायर इज मॉड्यूलस ऑफ एक्स. दिस इज व्हाट आई एम डूइंग. व्हाई आई एम डूइंग, आई विल लेट यू नो. If I write theta equal to 0 here, if I put theta equal to 0, it will be r square small r square minus 2 rr. So this will be capital R minus small r का mod की power 1 minus. Is that clear? एक काम करते हैं, टेक दिस इज 1, सो x की पावर 1 माइनस डेल को अपन ले लेंगे एक फंक्शन fx, तो लाइफ इजी हो जाएगी हमारी, इसको हम fx बोल देंगे. ठीक है, ओवरऑल अंडरस्टैंड दैट if my r is greater than r, that is if I'm lying outside the sphere, my potential as a function of r can be written as k capital Q on 2 1 minus del square, and I have this capital R small r, and then I can write it as f r plus r, because I have written x की power 1 minus del as some x की power 1 minus del as some f of x. And if r is greater than r, so, and मैंने एक चीज बताई हुई है कि मॉडुलस ऑफ x क्या होता है? इट इज इक्वल्स टू x if x is greater than 0, it is equals to minus x if x is less than 0. अंदर देखो क्या लिखा है, कैपिटल R माइनस स्मॉल r. लेकिन r अगर ग्रेटर देन कैपिटल R है, then this particular thing will become negative. तो आप क्या करोगे, you just take a negative of it. So this will be like f of, are you getting my point? ये चीज समझ में आई कि ऊपर से चली गई है?
हाँ नहीं आई।
है ना? So if r is greater than r, it implies this is negative. एक negative और आगे लगाओगे तो this will be like this. So this will sum up your potential as a function of r if r small r is greater than capital R. If small r was less than capital R, क्योंकि फिर मेरे को अलग से डेरिवेशन नहीं करनी पड़ेगी अगर ये मॉडुलस ले लिया। अगर स्मॉल आर लेस देन कैपिटल आर है, देन फाई आर ऑल दीज थिंग्स विल रिमेन सेम, के क्यू अपॉन 2 1 माइनस डेल स्क्वायर कैपिटल आर स्मॉल आर, दैट इज एब्सोल्युटली फाइन। दिस विल बी फाइन, क्योंकि प्लस में तो चाहे कोई दिक्कत नहीं होती। लेकिन यहाँ पर ध्यान से देखो, नाउ योर r is less than capital R, it implies capital R is greater than small r, that implies capital R minus small r is positive. Well, अंदर लिखी हुई चीज is positive, so you can return it as it is. So this will be your expression for potential less than R, this will be potential greater than R. The moral of the story is life was way too simple when we had inverse square law. Okay, so it took us almost 45 minutes to redo our only one expression. That is, only we are doing this potential function, nothing else. So potential function को formulate करने में we've had enough of difficulties. Is that clear? Or is that not clear? ये चीज समझ में आई है कि नहीं? हाँ ना तो बोल दो यार। ठीक है, ठीक है. So kindly remember this problem. This is a difficult problem and again very difficult. Okay, understand. जो हम गलती कर रहे थे बस वो ये थी कि if I am taking my sphere और हम लोग अगर इस तरीके से करेंगे कि रिंग्स में डिवाइड करेंगे, इफ आई एम रिमाइंडेड ऑफ द फॉर्मूला के क्यू अपॉन एक्स स्क्वायर प्लस आर स्क्वायर का रूट ओवर, मेरी गलती है बिकॉज दिस पर्टिकुलर पोटेंशियल फॉर्मूला इज वैलिड ओनली इफ योर इलेक्ट्रिक फील्ड वाज dependent inverse square law. So this formula I cannot use. I will have to reformulate the definition of the potential, which I reformulated here, and this indeed matches the answer of the book. This indeed matches the answer of the book, and I think uh, these are the newer results. Is that clear? So moral of the story is okay. So we are going to discuss a few more things because of this inverse square law forces. We'll see all these forces in greater detail while we'll be doing this central force. But overall, this sums up our lecture. Okay. I hope I have been able to explain. If there is a certain difficulty in the second lecture, you just skip those part and just try to see this, because there was some difficulty that I myself created because uh, just forgot that this cannot be the case. Okay. I'll meet you tomorrow.